Every LLM app has a hidden cost. If you're building an AI assistant using a large language model, every time a user asks a question, your app sends the model the same long system prompt, the same policy document, and the same product catalog. Only the user's question is new. So the obvious question is, why should the LLM process the same repeated context again and again? That is the idea behind prompt caching. It lets the model reuse parts of the prompt it has already seen, which can make repeated input tokens cheaper. In this video, we'll explain what prompt caching does, why it reduces cost, and why long context can still be expensive, even when caching is enabled. When we send a prompt to a language model, the model processes the entire input, which consists of the system prompt that's behind the scenes and the prompt you type. So if your prompt has 500 tokens, the model might process 500 tokens. If it has 50,000 tokens, it processes 50,000 tokens, even if most of those tokens were already sent in the previous request. This matters because long context systems often contain repeated information. For example, a support chatbot may include the same refund policy every time. A coding assistant may include the same repository instructions. From the user's perspective, it feels like the model remembers the conversation and simply continues from where it left off. But that is not exactly what happens technically. For each new request, the LLM receives a new input sequence, the system prompt, the conversation history, any documents or examples, and the latest user question. The model then processes those tokens again to generate the next answer. Even if most of the context is repeated, the model still has to work through it unless there's a mechanism to reuse part of that computation. That is the baseline problem that prompt caching is designed to reduce. Prompt caching is a way for the system to notice that the beginning of a prompt has been seen before. Usually, this repeated section is called a prefix. A prefix is the part of the prompt that appears at the start and stays unchanged across requests. For example, the system instructions are the same. The developer message is the same. A long reference document is also the same, and the first few examples might be the same. If those tokens appear again in exactly the same order, the provider may reuse internal computation from the previous request. The model still needs the context, but it may not need to recompute every intermediate representation from scratch. That reused computation is the cache. So what prompt caching says is we have already processed this exact prefix before, so we can reuse part of that work needed to understand it. That distinction is important. Prompt caching caches repeated input processing. Caching works best when the stable part of the prompt is at the beginning. That is because during generation, transformer models build on a prefix of tokens. Each new token is generated using the tokens that came before it. The model can process many input tokens in parallel, but the attention pattern still depends on the token order, because later positions can use information from earlier positions. So if the beginning is identical, the model can reuse computations for that repeated prefix. But if you place changing information near the front, you may break the cache. For example, let's compare these two prompt layouts. In the first layout, user-specific data goes first, then the current timestamp, the random request ID, system instructions, the long documentation, and then the user question. This format is bad for caching. The beginning changes every time, so the repeated documentation may no longer appear as the same prefix. Now compare that to this format, where you start with system instructions, the long documentation, few short examples, and then you have the user-specific data and question. This is much better. The stable information comes first and the changing information comes later. It's the same content presented in a different structure. This is one of the first practical ways to use prompt caching. It essentially rewards stable prompt architecture. Prompt caching can reduce the cost of repeated tokens, but cached tokens usually still have some cost, and even when they are discounted, several other costs remain. The model still needs to handle new input tokens, it needs to generate output tokens, it still needs to attend from new tokens back into the cached context. And the system still has to store, retrieve, and manage the cached representation. So if your application sends 100,000 token context on every request, caching may reduce the repeated prefix cost, but it doesn't mean it's going to turn it into a 1,000 token system. The model is still operating with a very large context, and large context can affect more than just the input price. It affects the latency, the throughput, the memory pressure, and it can also affect the quality of attention. Caching helps with one part of the problem, but the system level consequences of the long context stay the same. There is another subtle issue. Even if cached tokens are cheaper to process, the model still has to use the relevant information correctly. A huge prompt may contain the answer somewhere, but that does not mean the model will reliably find it. Long context creates an evaluation problem. The model may attend to irrelevant sections, or it may overweigh the recent information, or it may miss a small detail that's buried in the middle. Caching does not solve this problem. So, long context can still be expensive in two ways. It can be computationally expensive and it can be cognitively expensive for the model. The more irrelevant context you add, the more you ask the model to separate signal from noise. This leads to an important design question. Should we rely on prompt caching or should we retrieve only the relevant context? Retrieval and caching solve different problems. Prompt caching is useful when you have stable information that many requests need. Retrieval, on the other hand, is useful when you have a large knowledge base, but each request only needs a small part of it. A company policy manual is a good example. You could paste the entire manual into every prompt and depend on caching. That may work better than no caching, but it still gives the model a lot to read. A retrieval system works differently. It first searches for the sections with most relevant data to the question that a user has asked, and then it sends only those sections to the model. Now, the model receives less context, and the context is more focused. Caching reduces the cost of repeated tokens, but retrieval reduces the number of tokens you send. Those are different levers. In a strong production system, you often use both. Stable instructions are cached, dynamic knowledge is retrieved, and the user question comes the last. That gives you a prompt that is cheaper, faster, and easier for the model to reason over. So here's the practical way to think about prompt caching. Use caching for stable repeated context. Use retrieval for large searchable knowledge. Use summarization for long histories where the exact wording is no longer needed. Use structured tools when the answer depends on precise data. And use long context when the model truly needs to reason across the full material. Prompt caching is not a replacement for prompt design. It's a multiplier for good prompt design. When the prompt is stable, organized, intentional, caching can reduce cost and latency. When the prompt is messy, dynamic, and overloaded, caching may help much less than expected. So, prompt caching changes the economics of long prompts, but the basic principle stays the same. Every token you include should have a reason to be there. Cache tokens may be cheaper, but they still shape things like latency, reasoning, and system design. So the goal is not to stuff everything into the context window and hope that caching saves you. The goal is to separate what's stable, relevant, and what actually needs to be reasoned over. This is how long context systems become practical. I hope you found this information useful. Please subscribe to Scovia and, as always, stay curious.